Hey there! A few days ago I was bored in class, so I decided to start writing a Lisp. Came home, finished it up. Next day I added a few more features, and here I am showing it to you. I've always wanted to write a Lisp and learn Lisps. Um, so this was a good place to start. Because I don't know very much about Lisp, this is a pretty bad Lisp, all things considered. But we have dynamically scoped variables, we have lambdas, we have numbers, which are backed by a big rational. So that means big int. I mean, the host language has a big int by default. So, but in effectively infinite precision for decimal numbers, they're expressed as fractions. We have basic comparisons, we have booleans, and we have none. I implemented this in Python as a bit, just like trying to figure out like how much can I lean on the host language. Turns out quite a bit. Implementing in Python was a bit of a pain though, because I don't like dynamic typing, and the interpreter is about 300 lines, and it's reaching the point of complexity that I don't like dynamic typing for anything more than tiny scripts. Anyway, this is a bit of example code. This adds together all of the even Fibonacci numbers which are less than or equal to this big number. This is a rather contrived example, but this is the result of some code golfing I was doing with some friends a few days ago. So of course I rewrote it in this Lisp I was writing at the time. So we can run it. Ta-da! And we can. There's no looping, so using recursion, this will Stack Overflow if you go far enough. If you notice, I don't have like any way to define a function besides assigning a lambda to a variable, which means I can come in here and I can say def var func lambda, no arguments. I'm going to say print this is the original function, and we say func, and let's double check that that runs. Yep. And then I can come over here and I can say set var func lambda print this is the modified function, and then I can come over here and say func again, and we get the original and then the modified. So first class functions, you can pass them around as arguments and such. We can show off some recursion real quick. So say we want to count up to 10. We could say def var count to 10. Actually, count to n. We give n. And then we say in here what we'll do is we can first add. Actually, what we need to do, we need to have current. We can add to current 1, and then we can print. Oh, no. Actually, I can make that be one expression. Hold on. I can print set var current plus 1 and current doot. And then we can say if n is less than, no, if current is less than n, then we can count to n, give our current. Otherwise, we don't do anything. And then we can count to n. Our n will say 10, and we can start at 0. Unknown symbol n. That is going to be a pain in the butt to debug because I was writing this in a very hacky way. If I was writing this in a proper way, I'd like have all sorts of line number information and column and span information for giving like where in the program the error occurred from. Oh, I'm dumb. I keep making this mistake too. There we go. There we go. 1 to 10. Yeah. So that's, and if we were to give like a really big n, it will Stack Overflow. What if 100? Yeah, it can do 100. That's about it. It's a very simple little language. There's no macros. There's no looping. You can create a list. I can say print list 1, 2, 3, 4. Yeah, 5. And we can print that out as a list. But there's no way to like interact with that afterwards. Well, we can. I'll show real quick because we can divide, let's say, 5 by 2, and we get as a fraction, and then we could add to that 5 divided by 3. We should get. I don't remember maths. I'm dumb. Wow, that was stupid of me. Okay. Anyway. Why did I think that was going to work? That was really stupid of me. Anyway, it shows that I wrote this all in Python. I really did not enjoy writing it in Python. Like, I really didn't. Like, ugh, it's horrifyingly bad. I hate it so much. But some of the cool things about that is GC out of the box, a strongly typed dynamic type system out of the box. It's acceptably fast. I was talking to some friends about this, and they were like, oh, "You could have done it in JavaScript, and it would have been like really fast, because JavaScript engines generally have really good JITs." And I was like, "Yeah, I could have done Lua as well, but those languages have some severe issues that I'm like." JavaScript has type coercion, and all numbers are doubles, and then Lua has all numbers are doubles, and everything that's not a number or are strings tables? I don't think so. But everything else is just a table, including your arrays and lists or whatever they call them in Lua land, which has some really weird semantics with counting your length. If they're like wholes, it's really weird. If I was writing this like to be actually used, I would use something like Rust or something. But there are a lot of things in here that I wouldn't do long term. But one of the cool things about writing it in Python was, in addition to a nice dynamic type system, and a nice GC, which is important for Lisps. Well, I know there are static type Lisps, but we're ignoring that for now. The fact that by default integers in Python, well, technically they aren't big ints always. They're turned into big ints behind the scenes when they become large enough to require it. And then we have there's a fraction type in the standard library, which is basically just a rational with those big ints, right? So that was cool. Zig also has big int and big rationals in their standard library. Rust does not. However, there's at least one seemingly high quality implementation on Craze.io. So anyway, that's about it. There should be a link a GitHub link in the description. It's kind of crappy code. Like it's really short. Like it's this about 300 lines, right? Oh, I didn't mention it. All of the symbols are interned as well. There's no quoting, but all the symbols are interned with a numerical ID. If I can find interned, yeah, there's a numerical ID that. So looking up symbols for like function calls and variables and stuff like that is not as expensive as it could otherwise be, because it's not constantly hashing and looking up by string. Instead, it's hashing an integer, which is a lot cheaper. So, anyway, thanks for watching. See ya.